switching regulator, or switched mode power supply, SMPS. Crazy engineers. Limitations of linear voltage regulators. Bulky input step-down transformer. Most expensive due to low line frequency, 50 Hz. Large values of filter capacitors required to reduce ripple due to low frequency. Efficiency of series regulator is very low, 50%. Input voltage should be greater than the output voltage. When input equals 10 V DC then output equals 5 V, 50% efficiency. Greater the difference in input-output voltage, greater the power dissipation. Switched mode power supply, SMPS, overcome these difficulties. Hints. Bulky transformer. Expensive. Large filter capacitor. Low efficiency. Input voltage greater than output voltage. More power dissipation. Switched mode power supply. It is also called a switched mode regulator. This operates in different way compared to conventional series regulator. In series regulator, the pass transistor is operated in linear region to provide steady current flow, whereas, in switched mode regulator, the pass transistor is used as a control switch, which operates in cutoff or saturated state. So, the power transmitted through the pass transistor will be pulses, rather than steady current flow compared to series regulator. Since the pass device is used as low impedance switch, greater efficiency can be achieved. When the pass device is at cutoff state, there is no current, and dissipates no power. When the pass device is at saturation state, a negligible voltage drop appears, and dissipates very low power providing maximum current to the load. In both cutoff and saturation state, the power wasted is very little, and almost all power transmitted to the load. Hence in switched mode power supply, SMPS, the maximum efficiency of 70 to 90% is achieved. Pulse width modulation. SMPS rely on pulse width modulation to control the average value of output voltage. The average value of repetitive pulse waveform depends on the area under the waveform. If the duty cycle is changed, the average value of voltage also changes proportionally. Switched mode power supply block diagram. The figure shows the block diagram of switched mode power supply. The block diagram consists of bridge rectifier, thermistor, reference voltage regulator, high-frequency transistor switches, main power transformer, two-stage LC filters, voltage comparison amplifier, triangular waveform generator, pulse, width, modulator, and steering logic circuit. The bridge rectifier and capacitor filters are connected directly to the AC line to give unregulated DC input. The thermistor RT limits the high initial capacitor charge current. The reference voltage regulator is the series pass regulator. Its output is regulated reference voltage Vref, which act as power supply voltage of all other circuits. The current drawn from Vref is very small, till 10 mA, so the power loss in series pass regulator does not affect the overall efficiency of the SMPS. The transistors Q1 and Q2 of high-frequency block are alternatively switched on and off at 20 kHz. These transistors are either fully on or cut off, so that they dissipate very low power. These high-frequency transistor switches drive the primary of main transformer. The secondary of the main transformers is center tapped, and full wave rectification is achieved by diodes D1 and D2. The rectified unidirectional square wave from the diodes is next filtered through two-stage LC filter to produce V0. The regulation of V0 is achieved by feedback circuit, consisting of pulse width modulator and steering logic circuit. The output voltage V0 is sampled by R1-R2 divider, and a fraction, R1 divided by R1 plus R2, is compared with fixed reference voltage, Vref in comparator 1. The output of this voltage comparison amplifier is called V-control. V-control is applied to negative input terminal of comparator 2, and a triangular waveform of frequency 40 kHz is applied at the positive input terminal. It may be noted that a high-frequency triangular waveform is being used to reduce the ripple. The comparator 2 functions as a pulse width modulator, and its output is a square wave VA, of period T, F equals 40 kHz. The duty cycle of the square wave, is T1 divided by, T1 plus T2, and varies with V control, which in turn varies with the variation of V0. The output via drives a steering logic circuit. Steering logic circuit consists of a 40 kHz oscillator, cascaded with a flip-flop to produce two complementary outputs. These two complementary outputs are given to two AND gates to produce output waveforms VA1 and VA2. These two output waveforms of steering logic circuit are applied at the base of transistors Q1 and Q2. Depending upon whether transistors Q1 and Q2 is on, the waveform at the input of the transformer will be a square wave. An inspection shows that the output current passes through the power switch, consisting of transistors Q1 and Q2, inductor having low resistance, and the load. Hence, using a switch with low losses, transistor with small VCE, set, and high switching speed, and a filter with high quality factor, the conversion efficiency can easily exceed 90%. If there is a rise in DC output voltage, V0, the voltage control of the comparator 1 also rises. This changes the intersection of the V control with the triangular waveform, and in this case, decreases the time period T1 in the waveform. This in turn decreases the pulse width of the waveform, driving the main power transformer. Reduction in pulse width lowers the average value of the DC output V0. Switched mode power supply circuit diagram, and its waveforms, stage by stage is shown in the figure. Why SMPS has better efficiency than linear regulated power supply. We have noted that very high frequency signals, about 40 kHz or more, are being applied. The transistors Q1 and Q2 are acting as the switches, and become alternately on and off at a frequency of 20 kHz. Again, the transistors Q1 and Q2 is on for very small duration, and consumes negligibly small power, since VCE, set, 0.2 volt, is small. It may also be noted that the high operating frequency used for the switching transistors allows the use of smaller transformers, capacitors and inductors. This allows a decrease in size and cost. Limitations and precautions to be taken with switching power supplies. Since the rectifier is tied directly to the AC line voltage, the rectifiers, capacitors and switching transistors must be able to withstand the peak line voltage, 310 V for 220 VAC RMS line. The resistor RT must be provided to prevent the uncharged capacitors from shorting out the line when initially turned on. A switched mode power supply is more complex and requires external components, like inductors and transformers. It is slow in responding to transient load changes, compared to the conventional series regulator. One should be careful about the electromagnetic and radio frequency interference while using switched mode power supply. The switching regulator system is quite a complex one. However, with modern microelectronics, quite a few packages are available. The Motorola MC3420-3520 is a pulse width modulator IC chip. The Silicon General SG-1524 produces an IC package containing reference regulator, pulse width modulator, consisting of sawtooth oscillator and comparator, comparator 1, transistor Q1 and Q2, the steering flip-flop and 2, and gates. Thank you. By Crazy Engineers.